So welcome back, and in this video we're going to go over my predicted paper 1 for 2024, the OCR spec, which you can find in the link in the description, or as you can see over here, GCSE Computer Science tutor.versal.app. You can use this as like revision, and make sure you attempt it before watching this video. If you can do this paper, I'm guaranteed you can get a grade 8 or grade 9 in the actual GCSEs coming this May. Without further ado, let's begin this paper. And question 1 is basically, Ben has designed a computer using von Neumann architecture. Describe the purpose of two registers that are used by the von Neumann architecture. So everyone should know this. You have MAR, which is the memory address register, MDR, which is the memory data register, program counter, which is, and also the accumulator. So we can do any of the ones that I said, and let's pick MAR. So that's the memory address register, which that's 1 mark. Now we need to explain it. So what it does is basically stores the address of the data to be fetched from, or the address where the data is stored. And similarly here we can have the MDR, which is the memory data register, which basically stores the data itself, which has been read from main memory or is about to be written to main memory. We can also have program counter, which is basically stores the address of the next instruction and also increments by 1 to account for the next instruction. And we can also have accumulator, which just stores the results of calculations. Hopefully that one should be not too bad for you. But now let's move on to part B, which is state what is meant by a single core 3.5 GHz processor. So cores, what is a core? A core is basically one processor. So if we have a dual core, we have 2 processors and double the power. So since it's a single core, we can say single core means there is only 1 processor. And now we have to describe what is meant by 3.5 GHz. So 3.5 GHz means it can run 3.5 billion FDE cycles per second. So yeah, if we had maybe 4.5, that would be 4.5 billion FDE cycles. So hopefully this wasn't too bad, and this was again 2 marks. So yeah, let's move on to question 2. So we have a table and we basically need to fill it out for 4 marks. The first one basically, so hexadecimal, remember, to convert it from binary to hexadecimal, we basically split the bits up, remember? So on the right, we're gonna have the value 2. So the value 2 is gonna be 0, 1, 0, 0. And on the right hand side, we're gonna have 1, 0, 0, 0, 1. And that's basically what this is. And in denary, again, because 1 to 9 is basically just the numbers, we can get away with just writing 12 here. Now, the middle one, again, we're gonna follow the same procedure. So 8 on the right hand side, which is 1, 0, 0, 0, and 2 on the left hand side, which is that. And now if you try and calculate this, so 128, 64, 32 plus 8 is 40, hence why there's 40 there. And here we're gonna do the same thing and split this up into 2 bits, 2 partitions. So the right hand side, which is 1, 2 plus 4, which is 6, And on the left hand side we have 1, 2 and 4. 4 plus 2 plus 1 is 7. So 76. And if you add this up like using normal binary, you should get 118. And again, same thing here, we're gonna split it up, and this is gonna be 8 on the right. And on this side is 111, so the maximum, which is 15. But we're not gonna write 15 here, but instead 15 in hexadecimal, remember, is F. So we're gonna write F here. So for this one, we basically, remember, we draw a table, so 16 to the 1, and 16 to the 1, 16 to the 0, 16 to the 1, and we draw a table, and we put F8 here, and F corresponds to 15, so we do 15 times 16, plus 8 times 16 to the power 0, which is just 8. Which you should get the value to be 248. And this is how you do this question. Now, part B, how many unique values can be represented by a 5-bit number? So, with a 5-bit number, we have 5 spaces. So, 1, 2, 3, 4, 5. And each space, we can either have a 0 or 1. So, each has 2 possibilities. So this one has 2, this one has 2, this one has 2, 2 and 2. So if we do 2 times 2 times 2 times 2 times 2, 2 to the power 5, that is the same as 32. So 32 different possibilities we can represent using 5 bits. Now part C, perform a binary shift of 3 places to the right. So the way that we can do this is basically the last 3 digits of this number basically get chopped off, and therefore we're left off with 1, 0, 0, 0, 1. And the 3 that we chopped off, we basically have to compensate at the front. So we just add 3 zeros and make sure it's a 8-bit number. So 1, 2, 3, 4, 5, 6, 7, 8 is perfect. So, and again, remember, if you move it to the right, it's the same as dividing by 2, and left is multiplying by 2. Okay, part D, tick one box to identify the largest file size. So this is a bit of a tricky one. Not really a tricky one, but it can get confusing. So it's very important to convert these in a standard way. Just like in maths, how if you have percentage, fractions and decimals, you need to convert it into a standard way to compare them. So everyone should know this table. To go from 1000 to 2 million, we have to multiply by 2, and then how many zeros are we adding? 3. So we basically have to divide this number by 2000 to get the kilobytes of it. So if we do that, we should get 2000 kilobytes, which is clearly less than 230. And now, how do you go from kilobytes to megabytes? Well, you basically divide by 1000, which you get 2 megabytes. How do you go from 2 megabytes to gigabytes? You basically divide by 1000, so you get 0.002. So you keep dividing by 1000 and then you get gigabytes. The reason why we pick gigabytes is because that's the largest thing here. But I'm sure there's an easier way of explaining this to you, but I think you get the gist. So here we divide by 1000 so that we get the megabytes. So we get 2.3 megabytes. Again, divide by 1000, so we get 0.0023123. Here again, let's divide by 1000 and we should get 0.2 GB, and 0.1 GB is clearly less. So the greatest GB value is 0.2, and hence why this is the correct answer. It is 1 mark, but it's worth knowing how you can go from each thing. So yeah, make sure you memorize or know how this works. Let's move on to part E, which is basically adding the following binary numbers. So if you follow me on TikTok, you already know I've gone through this already, but let's see. So 1, 1, 1, 1, and when we have 2 ones, we basically represent 2 in binary, which is 1, 0. So we carry 1. Make sure you show your carries and not just write the answer. And 0, and 1, and 0. And remember, you put your carry bit here. And part F, what is meant by overflow? So this is called the overflow, and what it is basically, and that's basically what you have to say. Let me go back to typing. Cool. So here, part 3, we have a scenario where a student is performing a range of actions, and we basically need to give the most appropriate protocol for each. So downloading an email to your computer. This is a IMAP. Again, I've gone through how the protocols on my TikTok, or you can use POP. Ideally, POP is the correct answer, but you can also have IMAP. Downloading a text document from a web server. So we can either use HTTP, HTTPS, or we can use FTP, since we're downloading something from a file that's probably in a file server. File transfer protocol might be used, but it depends. Transmitting a file from a client to a server. Now, a file and server, we already know what protocol has that, which is the file transfer protocol. And the last one, which is everyone should get right, is HTTP and HTTPS, because requesting to view any web page in a browser uses HTTP or HTTPS. It's in the URL. So part B, some protocols have layers. Describe one advantage of using layers to construct network protocols. So layers, remember, layers are what? Each layer is independent, which is our first point. Dependent. If I can spell properly, which means what? If they're independent, that means that if we change one layer, it won't affect the other layer. So we can say that one layer can be changed without affecting the others. And what else can we say? I mean, this will be enough for 2 marks, but in case people write other things, we can say developers can develop separate things in different layers, so allows for standard manufacturers can develop hardware to fit one particular layer to group similar protocols together. It's just about knowing why we use layers. So as long as you write something that's equivalent to this, you will get the mark. So remember what layers are. Alright, next question. A company, GST Supermarkets, has supermarkets throughout the country, and they're using a WAN, which is a wide area network. One characteristic of a WAN is that they are set up over a large geographical area. Give one example, or give one other characteristic of a WAN. This is typical of them. They give they give you the basic one, and you have to find the other one. Because mostly, if they ask one characteristic, you would say it's a large geographical area. But here you're asked to find something more. We can say WAN uses external third-party telecommunications. I cannot spell. Telecommunications. Or we can have hardware or infrastructure. So yeah, commenting on about what they need to know, what WANs use, will get us the mark. Then we asked to find a benefit of using client server instead of a peer-to-peer network. Everyone should get this correct again, because a school is a perfect example of client server, where we have clients and every client is connected to the main server. So having that, all files can be stored centrally, and meaning that all computers can update the central database, or like the central place of where the files are, meaning that workers can access files from any computer, whereas with peer-to-peer, files will be stored on their own computer. So there are many more advantages. For example, backups are centralized, meaning that all data is backed up in the central hub and each client doesn't need to do it separately. Whereas with peer-to-peer, you have to back up in your own computer, as long as you explain it in the scenario. So what's the difference between the internet and World Wide Web? This is a common exam question which students don't really know. So www, the World Wide Web is basically the web pages that are stored on the servers. The internet is the infrastructure of networks. Again, the internet is a type of WAN, so it's an infrastructure of LANs. Part D, we have the supermarket introduces a wireless access point to allow network access to wireless devices. The manager has noticed that the performance of the network has recently decreased. So, describe how introducing wireless access could have slowed the internet down. So first and foremost, you should already know wireless is slower than wired. So you can comment about something along those lines. So wireless is slower than cabled. And why is that? Well, wireless can be limited by interference. As you know, even a small thing like walls, for example, walls can disrupt the signal. There you go. Wireless is slower, and why is it slower? Because the waves can be there can be collisions and also interfered by walls and objects that can distract the signal. We can also comment something about the bandwidth. As you know, it's shared and all that, but we can keep it simple for this example. So part E, we have the IP address. This is linked to the website with URL GCSE Computer Science tutor.verso.app. Again, if you haven't checked it out, I encourage you to do so. This paper is available there, as well as more topic-wise exam questions, as well as papers there. So yeah, go check it out. And once it's entered to the browser, the web page is loaded, and describe the relationship between the website URL and the IP address and the web server for 5 marks. So we have to go in detail So first and foremost, the website, we can comment something on the website. Well, the website is hosted on a server. So the website is hosted on a web server. Now, what happens? Well, the web server has an IP address. So the web server or website has an IP address. Now what happens? Well, the URL is sent to the DNS, the domain name system or server. Browser sends URL, the link to the DNS, which then corresponds to a IP address. So it basically like matches the URL to the correct IP address. URL has a linked IP address, which then DNS finds IP address. And if DNS cannot find the IP, it passes the request to higher DNS. And then lastly, IP address sent back to the browser. So yeah, this is basically how you can get your full 5 marks. I mean, each thing is a mark. So if you say this, spot on, 5 marks. You wouldn't even need to mention higher DNS. But if you know, might as well mention everything just to be safe. So yeah, hopefully this makes sense. And so question 5. Now this might be off-putting for many of you, but let's go it step by step. So what happens here is this is a bitmap image, which the letters are represented by a corresponding color. So W represents white, blue is B, and so on. So using the example in figure 2, explain how a bitmap image is stored on a computer. So first and foremost, images are made up of pixels. Each pixel can be one color. So a pixel can be one color, and each color has a unique binary number. And we can say the binary numbers are stored in order in the file. So for example, if this is like 000, then the first line will be some long binary number, if that makes sense. We can also give an example by giving numbers, but that's what part B is asking us to do. So part B, state what is meant by color depth and give the color depth required to store the image in figure 2. So color depth is, remember, how many bits used per pixel. So color depth is the number of bits used per pixel, and in this scenario, how much or how many bits would we need? So we have 1, 2, 3, 4, 5, 6 possible colors. If we use a bit depth of 2, we're only limited to how many possible combinations are there of 2? So 0, 0, 0, 1, 1, 0, 2 to the power of 2, which is only 4, which won't do justice. 3, let's try 3. 2 to the power of 3 is 8. So 1, 2, 3, 4, 5, 6, 7. So 3 will be required. So color depth of 3 is required, as there are 6 different colors, and color depth 3 means that There are 8 unique values available. Perfect, this should get us the full 2 marks of this question. Now, question C is explain how reducing the number of colors in a image can reduce its size. If we reduce the number of colors used to maybe 4, then as we calculated, we only need 2 bits, which is saving space, remember? So we can comment that and say fewer bits are needed per color, which means fewer bits per pixel. And number 2, we can give an example. So if we limit to 4 colors, we would only need 2 bits. We would only need 2 bits. Perfect. So 1 for what we'll do, and we can give an example. So part D, Alex needs to create an audio recording of himself singing. Explain how sampling is used to make the recording. So this is again gonna come up in your exam. So make sure you know how to do sampling and what is required in sampling. So in sampling, basically the height of the wave is measured. So when you sing or when you say something, there's like a wave, and whatever the height is, we're going to be measuring that. And we're not going to measure it like in random intervals, but instead we're going to measure it in set intervals. Measured at set intervals. For example, maybe it's every second, and then it's stored as a binary number, which then forms an approximated sound wave. This is what you need to talk about to get the full 3 marks. So the height is measured is 1. At set intervals, for example, every second is your second, and it's stored as a binary, would give you a 3rd mark. But we just went the extra mile in case you missed this out and you write this. So ideally, you get your ideally you know what this is talking about. Now, part II, state the effects of increasing the sample rate of the recording. So if we increase the sample rate, remember what is sample rate? Sample rate is again the number of samples taken per second, which is usually measured in hertz. So make sure you know that, and state the effects of increasing the sample rate. So if we increase the sample rate, automatically the file size increases, and what other effect will it have? Well, the sound will be a better quality compared to the original. And let's move on to part 6, which is binary numbers can represent different forms of data, as we've seen, and complete the description of how computers represent characters in binary using the given list of terms. So a character set stores something of the characters that the computer can represent. The character set stores all would probably make sense because none of the rest makes sense. So that one we can just do. Each character is given well, it can't be the same, can it? So unique, or we can say different. A unique binary code, lowercase and uppercase letters in a character set are given. It can't be the same because they're different characters. So again, we can use unique or different, or we could have similar as well. It depends on what character set you're talking about. One example of the character set is ASCII. This character set uses how many bits for each character? It uses 7. There's no 7, so 8. But it uses 8 bits for each character. I'm pretty sure it's 7. I don't know about that one. I would assume it's, unless I've missed something from the question, but there's no 7, so that's why I put 8. Unless it's a mistake on the paper. But anyways, if the code value for the character F is 70, then the code for L is, so we basically just have to count, so 71 would be the letter that comes after F, which is A, B, C, D, E, F, G, H, I, J, K, L, so 6, so 76. Hopefully that one makes sense. So you just count up and given whatever the value is here. Now we move on to the tick boxing exercise, which is which character set can represent European characters? Well, European is not supported by ASCII, but is extended ASCII and also Unicode. Uses different character codes for upper and lower case. Well, all of them do, because we've said up here that each of are given unique for lower and upper. So that will be all of them. And the last one can represent thousands of different characters, including Russian and Chinese symbols. Well, extended ASCII and ASCII are not supported by different languages, and Unicode is actually the only one that can support other language symbols and stuff. Question 7, which is the second last question, I think. And Hamish stores confidential documents on his computer, and he would like to use encryption. So explain how encryption helps protect Hamish's documents. So encryption is basically, it uses an algorithm to scramble the data so that if it is accessed, it cannot be understood. This is the point of encryption. So if someone does get the data, it will be impossible for them to work out what it was. It's not that it prevents that from happening, but it's actually, if it does happen, they can't understand it. So make sure you know that difference. And we can also add the fact, just to get the full 2 marks, we can add by using keys, so like public key, private key, to encrypt and decrypt the data. So yeah, this is what you have to write for part A. Part B says identify and describe one other software-based security method that will help Hamish protect his computer system and data. So we've given encryption, so we can't use encryption, we have to use another one, which we can basically just say firewall, which what it does is basically monitor incoming and outgoing packets and stops unauthorized traffic. So imagine in school, if you download like Fortnite or Epic Games, it will block it because they have a firewall which blocks the packets from that server. And that's basically how you can protect like random things from entering your computer, by using a firewall. We can also have other examples like encryption, not encryption. We can have other examples, for example, password, user access levels, and yeah, hopefully that makes sense. And part C, Hamish's laptop has both hardware and software. Explain why a computer needs both primary and secondary storage. So why do we need primary storage? Primary storage is basically RAM. RAM is needed so it can store the currently running data. So that's something we can talk about. Primary is needed to store active data that the processor needs to access, e.g. RAM, to store the currently running data. Or we can also say ROM, which holds the BIOS and startup instructions. And we can also have cache, which is to store frequently used data. And for secondary is needed to store permanent files, so that when you turn off the computer, the files are not disappeared. Because with primary, remember, when you shut down, it's gone. Well, it depends. So like RAM, it goes, but ROM, it stays. So it's usually stored, is needed to store long-term data, and without secondary, the user's files will not be stored when shut down. So yeah, hopefully that makes sense. You can have you wouldn't need this much detail, but we're just going over the possible scenarios. A few more to go. Question 8. Security on a computer can be provided directly by the operating system or by using utility programs. Store 2 utilities that can be used for security. So straight away we can use the ones that we used, which is antivirus, and a firewall, which are 2 examples of utility softwares. Or because it is security, we wouldn't really need like defragmentation and backup things, because those wouldn't be optimized for security. Now, part B, explain why memory management is necessary. So memory management, again, is when is to manage the memory inside the RAM. So whenever so we can comment on that. We can say memory management is used to control the use of the RAM and to share processor time between different programs and processes. So imagine, right, you're running multiple software, and imagine there was no such thing as memory management, and only one program is allowed all of the processing power from the RAM or the CPU. But for the RAM, imagine only one thing is allowed. So how can you multitask? You can't, because only one is allowed. So for example, just Google Chrome is allowed, all the rest like shut off. So you can't really multitask. So this is why memory management is useful, because it allows you to share the processing times between programs. So you can divide the RAM into chunks, and each chunk gets a different process. So running Google Chrome, one chunk gets running Spotify, one chunk gets running, I don't know, whatever you do, multitasking. But you kind of get the idea. This is why memory management is important. And what it also allows you to do is allows programs larger than main memory to be run. So because it splits it into chunks, you can allow more programs to be run. That's less than what the size is. So yeah, hopefully that makes sense, and make sure you know memory management, because it is a high topic, high probability that it will come up. Part C is basically it's a virtual memory question, and we need to rewrite some of them, and if they're already true, you don't need to rewrite them. So here's the question. The first one, a section of primary storage is partitioned to act as a virtual memory. Well, from part B, we already said that RAM is shared between different process times, and that's not the same as virtual memory, so don't get confused. And instead of primary storage, it should say secondary storage, because it actually uses whatever hard drive or SSD you have inside. A section of it is dedicated as virtual memory because the RAM is full. So how can the RAM, if the RAM is full, how can the RAM be used as a partition to act as virtual memory? So yeah, section of secondary storage is partitioned. You're supposed to write the whole thing, but for convenience, I'm just going to write that much. You can fill the rest in. VM is needed when RAM is full or nearly full. Is that true? Yes, it is. This is the whole point of virtual memory. RAM is full, hence why we need a section of secondary storage to put those applications on. That's virtual memory. Data from virtual memory is transferred back to secondary storage when needed. Why would it be transferred back into the same place where the virtual memory is? That doesn't make sense. So that's why transferred back to RAM when needed, or primary storage. And again, you're meant to write the whole thing out again and correct it. Data from ROM is transferred into VM. Of course, this is clearly false, because what's stored in the RAM and the ROM, the BIOS and startup instructions. So that is totally false, and instead of RAM, it should be data from RAM is transferred into VM. So yeah, not too bad of a question. They can easily make this into a 4 marker. So yeah, make sure you know what virtual memory is and what happens in virtual memory. And last question, final question. Layla is a software engineer. Layla is a software engineer. She is creating a new version of a computer game she released 3 years ago. She is considering selling the game online and not making it available in the shops. So what's the environmental impact that this can have? Well, clearly, if it's not distributed, you're not really wasting any material. So hence less plastic for the CD cases or whatever is used to manufacture, and less electrical power is needed. This all contributes less electrical power is needed, which all contributes to no petrol used to distribute, which contributes to a smaller carbon footprint. As long as you mention any of these, you should get it right. So yeah, make sure you know the environmental impact. That's something like you can use your geography skills in handy to answer this question. Part B, Layla released a game under a proprietary license. So explain why a proprietary license is more suitable than open source. So proprietary basically means that you need a license, and versus open source, which means the code is available outside. So what this means is that she can sell it for a fee and make money, and protects her source code. This is an important fact that you must mention. So it can't be copied, which allows her to do whatever she wants without other people interfering and changing the code, as well as other people copying the code. Here's the last question. Basically, it's an the legislation question. A company transmits personal data to another company without the permission. This is something to do with the data, so that's why it's the Data Protection Act. The school accidentally publishes the students' addresses on the school website, which is again data, hence why it's this. The interface for a piece of software is copied, replicated by a rival company. This is to do with copyright because it's copied. A user leaves a computer logged on for another computer, another person leaves them a message on their desktop. This is basically misusing the computer or using it to harm other individuals. And the last one, a student guesses the teacher's password and access their computer account, is also a misuse act. So yeah, hopefully this video is helped you, and if it did, be sure to smash that like button, subscribe for more videos, and yeah, comment down below how you found this paper, if you did try it. If I've missed anything, let me know. And yeah, let's get this YouTube channel to 1K, and let's help as many people out as possible. So go share with everyone, and yeah, make sure you know how to do this question, and this mark scheme will be available on the website very shortly.